So let's take a look at this empirical formula problem. So we've already talked about this in lab and in lecture a little bit. So say I send this compound, I make a compound in the lab, and say you send it off for elemental analysis, which is basically just mass percent. That's all it is. And it comes back. It says that carbon is 40%, hydrogen is 6.72%, and oxygen is 53.30%. Also, say you ran this through a mass spectrometer, and you came up with a molar mass of 360.0 grams per mole. We want to figure out what the empirical formula is, and then eventually we want to figure out what the actual molecular formula is. So a couple of things. Whenever they give you a percentage, just change it to grams. They say assume 100 grams a sample, but just change it to grams. So I have 40.00 grams of carbon. Do the same thing with hydrogen, and then do the same thing with oxygen. So they give you a percent, make it grams. And then whenever we do empirical formula, you want to get the moles of each individual element. And then we divide by the lowest number of moles. So I go from 40 grams of carbon change it to moles, divide by molar mass. I'm going to do the same thing for hydrogen and oxygen really quickly. One thing when you're doing this, don't round off the moles too quickly. Write down like 3 or 4 or 5 digits. Let me go ahead and do that. Okay. So we got the moles of each individual element. We're going to divide by the lower number of moles. Let me go ahead and rewrite this now. Let's put these moles as a subscript. So I've rewritten this as the subscript, and then we divide by the lowest number of moles. So the lowest number is going to be 3.331. And you want to round off to the nearest whole number. So for carbon, that's going to be 1. Oxygen is going to be 1. For hydrogen, it's like 1.998. When I divide this, just round it off to 2. And so your empirical formula is CH2O. So the second part is, if they give you the molar mass, it's 360 grams per mole, I need to figure out the molecular formula, what the actual number now of carbon, hydrogens, and oxygens are to each other. The way we're going to do this, we're going to use this formula right here. We're going to get the molar mass, which is going to be 360. We're going to divide it by the empirical mass. The empirical mass I've already done for you. It's just the molar mass of the empirical formula. So the empirical formula, we determined that a second ago, CH2O. 1 carbon, 2 hydrogens, and 1 oxygen. We add up its atomic masses, we get 30.3 grams per mole. So let me go ahead and plug this in. You end up with 11.99. It should be close to a whole number. Let's just make that 12. Once we've done that now, I'm going to multiply the empirical formula by 12. So I'm going to divide, or multiply rather, carbon by 12, hydrogen by 12, and oxygen by 12. So C12. So C12, H24, O12, that's the actual molecular formula of this compound.